Good afternoon, friends and colleagues. I wish I can say it like Vidya Balan does in Munna Bhai. I can't. So good afternoon to all of you. That's the best I can do. What I'm going to talk about today is not what we should do and why we should do. I think we heard a lot about that already. What I'm going to try to do is talk about the larger context and given the larger context, how all of us can cooperate with each other to achieve what we need to achieve. What has been already laid out very well so far during the day. And essentially that is what IESA is about, right? I mean, we are an association of the companies that is trying to make in India, for the world, all those sort of good things. So before I lay out the larger context, and the setting of the context is like being blind and trying to describe an elephant, right? This is even more complicated because the context we are trying to set is of uh, historical importance and of the global reach. But my perspective, so I'll try to explain it from my sort of perspective. And my perspective comes from my trying to make Sankalp sustainable and scalable over last several years. So I'll talk a little bit about Sankalp first. So Sankalp has global locations, multiple locations in India where we do the delivery of the work we do. But we have global centers where we try to take care of actually customer sort of concerns and issues. So in that way, Sankalp, when we say make in India for the world, I would rather change the word make to do. So Sankalp does things in India for the world. So what exactly do we do, right? So what we do is essentially semiconductor chip design services. And the way we see it, that it is a layered approach. So today, Sankalp is able to do all your chip design services. And ISA is full of semiconductor companies, so I'm sure I don't have to explain this too much. But in short, we do digital services, analog services, front-end services, back-end services. We do on-chip services as well as off-chip services. Now, when you start doing something, you want to make sure that you do it in a way that will guarantee the sustainability and scalability that I talked about earlier. So from the time that Sankalp started, which was about 10 years ago, Vivek, who is here, he started it. The focus was what we call TIE, but basically trust, integrity, and excellence. So there has always been focus on do as best as we can on those three vectors. And then customer first, so obviously we are here to solve actually customers' problem, but grounds up, right? I mean, we don't want to take shortcuts, we don't want to solve the problems of the day and then run away. We want to do it grounds up. What do I mean by grounds up? So, although earlier somebody talked about that skilled engineering wise, India has done well. I think there are still challenges in the semiconductor portion of the design and manufacturing. So there we still have to build talent. And Sankalp prides itself in developing homegrown talent instead of just trying to get engineers from some other company and survive on the basis of that. We also have multiple design centers in India, and that goes hand in hand with the first point that I mentioned. If you want to train people, you want to be close with the engineering colleges and also ideally give them jobs there. I mean, I think Bangalore is crowded enough, right? Operational excellence I already talked about. And all these leads to the buzzword that also I think Vivek threw around, which was actually customer delight. So that's how we do things at Sankalp. Where have we been now that we have 10 years old? I would say that we have done well. Generally, we have been doing about 3x in revenue every 3 years. And more importantly, if you look at the last 3-4 years, in 2012, we were fortunate to have an opportunity to have cooperation or the merger with KPIT Semiconductor Services Unit. And this is one of the examples of the cooperation that I'll talk more about later. And just few days ago, we announced that we have done the similar thing with Intera systems. And with some of the other things we have done in the last year, I'm very confident that for several more years, we should be able to keep this trend of 3x in 3 years kind of actually going. So that is for as far as the Sankalp. Now, if I talk a little bit about myself so that you understand where do I come from, at the risk of giving away my age, I would like to say that, I look at my life in the last 4 decades as very formative years. So the first decade, when I was, from sort of teens to mid-20s, I was a very driven student, which took me to some of the top institutes in the world, and I think of that as being very fortunate. Then I worked with IC companies, system companies, and IP companies, mostly as an engineer or engineering lead and things like that. I think the most important change that I made in my career was after those first 2 decades, where I was first made responsible for making sure that actually customer systems do not have any obstacles or hindrance because of adoption of Rambus technology. And that's where I started to unlearn some of the things that I had learned earlier. I think we all are inherently very competitive. And I had to go from competition model to cooperation model. And the last decade brought me closer back to home, because otherwise, until then I was in the Bay Area. I'm still in the Bay Area. But in 2005, I had an opportunity to come work in Bangalore. And since then, mostly due to Sankalp, I've been working in India more than I should say outside India. Especially if you count all the time you spend on the phone across the oceans. So that is where I come from. And now what I'll try to do is set the context, the larger, broader context from my viewpoint. A lot of people have talked about the opportunity we have in front of us to transform India to the next level of economic growth. If you put it in perspective, in an historical perspective, I think the opportunity is even larger. We have an opportunity to take part into transforming the world from information age to intelligence or knowledge age, right? So we just had an automotive panel, so I'll use that example. In the agricultural society, we were using some vehicles like bullock cart or whatever, but they were not powered. They were not actually machine powered. They were man or animal powered, right? Then we came to the industrial age, and we talked about automotive a lot. We have car, but today, if you look at, there are all kinds of battery operated, electricity operated, gas operated tools and things. But sticking to the car, you go from bullock cart to bus or a automobile. Then comes, again, going back to the panel, what they said, intelligent driver and stuff like that. So now we are giving him a lot of information. So information and industrial output, industrial products are now being merged. But what is going to happen now in the next transformation is that we are going to add intelligence to the tools, the gadgets, the vehicles themselves. So somebody asked earlier the question, when can we see driverless or the self-driving cars? My gut feel is that at least in the Bay Area, you will see them being bought by people like you and me in the next 5 to 10 years. Google is already driving them, and it is gathering massive data. And all the problems of accident and would you risk, would you see enough value? Of course not. I'm not going to put my kids in a self-driving car and say, okay, Tata, go to school. But I don't have any problem Google giving me free delivery at home from Costco or Target in a self-driving car. Who cares, right? And somewhere, somehow the market has to start, and I think the time has come. It will happen. But that one example tells you how we are transforming the world. So world is transforming, and we have an opportunity to be part of it. This also has been talked about a lot, the number of devices, right? So I'll not spend too much time on this, but we all kind of see this coming. I don't think, maybe I was not paying attention, but upcoming trend being hyped as much as what IoT has been hyped right now. And I think it is for real though. But the point I would like to really make is that it's a variety explosion, and this is from the perspective of a chip maker, right? So far what has happened is you can have millions of cell phones, hundreds of millions of cell phones, maybe tens of millions of tablets, but they're not very different from each other. Yes, Google and Apple can fight over whose operating system is better, and if you're not technology savvy, you can vehemently argue that iPhone is better than Android phone. But for most of us geeks, they're not very different from each other. I can switch from one to other any day, right? What is going to happen now? What type of chips the world needs going forward? It's not going to be one chip with 100 million units or one chip with 10 million units. It will be multiple chips, thousands, 10,000 chips in volumes as small as 10,000 or 100,000 units. Obviously, it depends on the ASP of the price. But what we tell our actually customers, these are the system customers, that if your electronic spend is few $1 million, let's say between $1 and $10 million, you should start thinking about making a chip, right? Why? Because it will be necessity. You will have to be able to make the chip because off-the-shelf parts will not be available that are right for your application. But also it's an opportunity. If you can do a chip according to your features, your specifications, then you will have an advantage in the market. What drives this variety explosion? So obviously the applications, right? I mean, whatever else we say, ultimately if there is no necessity, if there is no need, if people of the world don't want certain things, then you're not going to be able to make an economic proposition that is viable. So explosion is driven in variety by obviously the need or the like appetite of like people for all these gadgets. But, and you know, industry tries to cope with it. So we try to streamline things, we try to standardize things. So even if we try to form alliances, even if we have standards, you will see there are multiple of standards. What I've tried to put on the slide here is just for the wireless. There are so many alliances for wireless interface, and there are so many standards. So there will not be one standard, there will be multiple standards. And then on the top of that, you know, we talked about hardware, and somebody asked about fab in India. But there is no one fab. I mean, you know, today more chips are being made in 35 microns, 3.5 microns, sorry, which was the technology they were using in 1983 when I started working, right? Then they are made in 16 nanometer. So the whole actually plethora of process nodes offered by many, many different competitive foundries is available. And for a person who wants to build his system or a chip, he will pick the right one. And it will be market driven, it will be economics driven, right? So if you want to do a fab in India, which one to do? Which node to actually focus first? There are lots of, I mean, they answered it very well. It's a very complicated sort of actually question to answer. But for my purpose here, these are the things that drive variety. And variety is the life, I mean, is the essence of life, right? Because what is going to happen if ultimately if we are all free and if we are if we all can afford, then we want something unique. We want something that kind of reflects our unique identity or our likes, our actually dislikes. That's what Apple has done so well, right? There is a humorous quote about standards. I mean, you can say standard is good, but I really like this quote, so I thought to bring some humor into this talk, that standards are like toothbrushes. It's good to have, but I don't want to use yours, right? So one way or the other, chip industry has to deal with variety of chips. So far, I've heard my fellow engineers working at Intel or TI or some other places being very proud that I'm making the next generation CPU, or I'm developing the next generation ADC. Or if it is the memory chip, oh, now we can put these many gigabits. I lost count. When I was doing it, it was 4K bits, right? But we are not making better of the same anymore. We'll have to deal with a variety of things. So essentially, industry has to find a way to deal with this variety explosion. A lot of people talked about design or manufacturing. Do you make? Meaning you do manufacture only in India, or is design also important? So that's where I use the word do. Let's do things in India, right? And do it for the world. So it is very simple from that point of view. But to give a different perspective, if I'm going to have variety of gadgets, they will be all interconnected through whatever, it's like a Matrix movie, but instead of some remotely driven human beings, there is going to be remotely, if not driven, at least all interconnected things and people and all sorts of things, right? So in that world, when I look at product, it is very hard for me to even define it as a product or a service. I mean, just 2-3 days ago, Google surpassed in market cap to Apple. So now there is a services company that doesn't charge me anything for the services, right? And it has higher cap than a sort of actually product company. Would have vehemently argued 10 years ago that this can never happen, right? But it has happened. So in that world, I would urge you to break all the different boundaries that you may have used to kind of, channel your actually thinking. In that sense, when I get a service, maybe it is from one app, and I know there is a whole infrastructure behind it. The phone I use, whether it's Apple, iOS or Android and all that type of stuff. But to me, it has to be as appetizing as the dosa or the hamburger that I really like, right? And what makes that dish that I want to splurge on at that instant is lot of different things that all have to come together, right? We call some of those things software. We call some of the things hardware. We call some of the things design, some of the things manufacturing. But, and again, going back to Apple, iPod, they put everything together. And then you can say, well, their software was not better, their hardware was not better, their this thing was not better, then what was better? And since we don't have any better word, we say secret sauce. Okay, maybe their secret sauce. They had something, right? Steve, I just heard some interview where the guy was saying that Apple has lost that consumer touch, that anticipation of what will actually the consumer really like after Steve Jobs passed away. Whatever that is, but my actually proposition is don't think in this compartmentalized way. Because once we do that, we get trapped into scarcity mentality. We try to argue, no, design is more important or manufacturing is more important, right? They both are equally important. Software and hardware, and I'll talk a little bit more about it. There was an artificial boundary. For the last 2-3 decades, we had to use most of the chips that were available off the shelf. But that boundary is erasing, or it's kind of going away. It is becoming more actually porous. And that is the change, at least in a smaller way, that will be fundamental to at least what Sankalp does, and I would actually propose to most of the people here in the room, because we all are one way or the other focused on doing chips or hardware, right? So design and manufacture intertwined. Later on you will see Sankalp is trying to do manufacture aware design or manufacture conscious design. Similarly, I've heard people talk about design led manufacturing. You cannot just do manufacturing where you are not aware and being able to cope with, let's say, if there is an explosion of devices, to deal with more than one device. Then your manufacturing plant is not of that much value, right? All right. So, unique thing about semiconductor industry. So now from global context, I am slowly coming down to semiconductor industry, right? So, going back to the automobile example, and my thought process was also tuned to that, which is you do the design. Some guy in Italy maybe sort of sipping wine, he just does some nice design for an automobile, sells it to Toyota or somebody, and they then work very hard and try to make a car. So the process in my mind was very simple. You design, then you manufacture all the different components, and then you assemble. But when you can put the entire system on a chip, I think the order of design, manufacture, assemble is actually getting topsy-turvy. What we do today, what we call chip design these days, is essentially we do the block design and then we assemble them on the chip. Once they are assembled, before we throw it to the like over the wall to manufacturing, to the semiconductor foundries, we have to be very careful because a single bug is going to haunt us. So we do verification that, in my opinion, we need to do verification that is more rigorous than validation, right? So essentially what we call chip design is really design, assembly and verification. So how can we do these three things in that order for variety of chips? That is really the challenge. We have mastered how do you do it for the same kind of chips, right? If I have to do the next CPU core, I know the team who had done it. I throw some more actually servers that are even higher speeds because I'll need more actually compute power. And I can say what the technology will allow me to do, how fast can I go from 10 gig to 20 gig, and boom, boom, boom. It was more or less like understood process. I think now we are going in the zone of not having well understood how will we cope with all these different things. So my submission here is we'll have to do 4 things. One is innovation. Innovation is a very widely used word. And here what I mean by innovation is not just a design innovation, because that is the first thing that comes to an engineer's mind. Yes, I can do 56 gig SerDes, but that is one type of innovation. We also need to think about innovation in automation, in our space, in design space, innovation in verification, in our space, right? Things like that. Outsourcing. Collaboration to me really means, I think I really understood the meaning of word ecosystem in the last few years, right? You have to do your part well, understanding the broader context, and then cooperate with other folks, right? So outsourcing is mostly driven by just in time. Everybody has to get things out in a very short schedule, and to do that, it is a lot better to give that job to somebody. If you don't have to do everything, you just have to do one piece of the overall puzzle. Reuse, that's very obvious. And then cooperation or collaboration that I talked. How do you interweave these 4 elements into how you are doing things now? Because you can't throw away your existing model, which serves you well for your existing business. So you'll have to make continuous changes and adopt to how you will do things for this future emerging market. Right? So just little bit of IoT from my viewpoint. I would view the world, again going back to the Matrix movie analogy, there is some central nervous system that will do its thing, and for that it will need massively speedy actually computing power and whatnot. But talk about all the nodal things, which can be people, which could be things. So you want to build an IoT edge device that is residing somewhere on some nodal end of this massively complicated global interwoven network, right? And for that, it has its needs. If it is remote, if it is in Bombay, then flood. If it is remote in Nepal or kind of Ladakh, then you'll have to kind of worry about those temperatures, whatever it is. And you've got an order that I need only 10,000, I can spend so much in NRE, and the price per chip cannot be more than this. And with all those sort of constraints, you have variety of condiments to choose from to make your hamburger or your dosa. You can choose your CPU, you can choose your interface, you can choose your OS and all that type of stuff, right? So you get the idea. So I would like to coin a new word. We had talked about ASIC since the IBM was the ASIC king, and then LSIs and Toshibas and all came, and then eSilicons and open silicons, but those were application-specific ICs, not really full systems. So then we coined the word SoC, and those were SoCs for massive markets like cell phones and whatnot. So they were SoCs, but they were not, I mean, they were application specific, but few guys would do it, right? So how about SOC? Application specific systems on chip. And that I think in my mind describes the variety lot better. It will be really application specific, various systems on chip, because you can do so much on a chip, given all the different process options you have. So application specific system on a chip, SOC. The beautiful thing is, these SOCs, or at least 90% of these SOCs, anybody can make. Now anybody, meaning I'm not indicating that a commerce graduate can do it by himself, but you don't need to have a fab. You can do the contract fabrication, you can do contract manufacturing. You don't need to be an expert on the CPU. I mean, 20 years ago, if my friend bought a new PC, I'll say, how fast is the CPU and how much memory, right? Now, as a chip designer, I have a choice to put whatever CPU I want and whatever amount of memory I want, and maybe throw a few more things in, wireless, wired, interfaces, some analog functions like, power management, this and that, and I got the chip that I want. So chip making has been really democratized. In that sense, you can say hardware is becoming like software, right? That doesn't mean that anybody can do iOS tomorrow. I mean, that wasn't, that is obvious to everybody in the software industry. So equivalently, everybody cannot do the unseat ARM tomorrow, or can do better analog chips than actually TI. But there is an equal opportunity to do at least some chip somewhere, or at least make it for somebody who knows what he wants. So again, if you don't go for branding, if you go with the Foxconn or the TSMC concept, you make for whoever wants it the factory concept to the chip design, then from that viewpoint, we all can build a factory where we can do all this kind of variety of chips, right? All right. So far I talked about industry. Now a little bit about India. So my view on India, we are in the third generation of free India, independent India. And from semiconductor industry, we are in the second generation. And here each generation I'm counting about 25 years, right? You can say in the old days it could be 20, but now slowly it is stretching. And some of the things that I've observed now that for the last 10 years that I'm interacting a lot more is one is actually the sort of content of what we talk in forums like this. Just 4 months ago, I was in a forum called Global Business Forum, organized by IIT Bombay alumni. And they brought government, academia, industry, venture capitalists all under one roof. This is another example of that, right? We have a lot of different players. I mean, we talked about Foxconn on one end and Seagate and the large services providers like Cyient and all kinds of people all came together, right? So this is some data, and now the timing one can actually question, but general trend I would agree to, which says that if you look at Fortune 500 companies worldwide, the global Fortune 500 companies, and where they are headquartered. In the past, the India's portion was very, very small, with that thin green slim line, right? But in future, they say it will be as large as US. And it is very simple. We can say what all are the obstacles in doing A, B, or C, but the driver has to be the market. And if India is going to be the large market, and I would submit India is not only the 1.2 billion people market. I think somebody said it in the morning very well. The applicability of what we do for India in the rest of the world is going to be higher in the new world than the applicability of what you do for US market. Because yes, the aspirations is for everybody to be like what Europeans and Americans do, but reality is that the larger market is outside those regions. And so again, when I was listening to panel, They said make for India, it can't be hand-me-down products, totally agree. But those products will be equally applicable in China, in Brazil, in a lot of other parts of the world, right? So I do believe this trend, that India will be the place where the decisions of what products, when to launch what, how much money to spend in which area, which obstacle to attack first, all those things, the decision making is going to happen more and more in India. And this also will be an opportunity for India-based chip designs. Other point, India, and this also somebody talks, like 20,000 chip design engineers in India, and we do so many chips for the world, right? So we have the talent, we can do it. Maybe the global, the broader context, and the system expertise more from the physical side. I think we are good on the logical side, but we need to be a little better on the physical side, then we can do it. Other way to look at it, I think I alluded to this earlier. The vertical line is where, you know, you still sell the highest performance or the most dense memories or highest performance like processors and stuff. But if you look at the horizontal circle, the sort of SOCs, that is what will give an opportunity for a chip design factory, right? And from that sense, one can say IoT is really the time for India, because from our design expertise, learning from software, and factory, meaning we have to learn the manufacturing concepts, and we don't have to learn everything from India. The world is very small now, right? Sometimes I have to beg for work to be done from Hubli or Bhubaneswar, and I have to tell them that, you know, these days it is easier to move data than to move people. Please understand that, right? So same thing, what is happening here, to learn from anybody is not, there is no obstacle to it, right? People can come in less time from Beijing or Tokyo or New York to India than my forefathers took to go from Bombay to, let's say, small village in Gujarat. So the world has really become small. If we combine whatever we can learn from software industry and the manufacturing industry, then in this chip design area, we can take advantage of IoT and make that the time for India. And then you can argue whether that is manufacturing, that is design, did it bring more jobs or less? But you know, the reality of the life is the old type of jobs are not going to be there. It'll be all new type of jobs. I kind of remember when I was in high school, the most common essay was, should we do industrialization or not in India? No, we should not do, because it will take away jobs. Today we are saying, let's do industrialization, let's do manufacturing because it will bring jobs. But we have to move forward. Let's do everything. Let's do design, let's do manufacturing, let's understand how they intertwine with each other, and then we'll do well, right? I think I'm almost at the end. So I guess what I'm saying here is that variety explosion of electronic devices, which are primarily going to be made in a chip, along with the constraints like it has to be most cost efficient and just in time. That is the driver. That is what we need to adapt to. And the fact that India has been at it for a while, and it is easier to build these type of chips, actually anywhere, but especially in India. It's easy to build SOCs. The world is globalized enough, India has been part of it for long enough that we get it, right? I mean, when I went to US, to learn how to drive was a big issue. Now the kids come and they drive there on day one, right? I mean, they don't have any issues, right? So the fact that it is easier to build these SOCs, I think we have a great opportunity to be a hub, to be chip design factory. So I'm trying to play with the words design as well as manufacturing, both included in this new hardware that we'll have to build. And let's build those design factories. And obviously, this is my view, this is the role that I want Sankalp to play. I'm sure you all know why you want to do what you want to do and what you want to do. And hopefully this example gives you some idea as to how do you put it in a more larger context, and then how do we work with each other. Because I think that's another trait that Sankalp has. We would love to work with anybody and everybody. I mean, obviously there is some practical limits to who all you can work with, for anybody and everybody as well, because that service mentality is also important, but either or mentality has to go. You can do service and IP both. You can do design and manufacturing both. You can serve Indian market as well as the world market both. You can do all that, right? So thanks for listening to me, and if I have some more time, then I'll be, no? All right. Okay, so then no more questions, right? All right, no issues. So again, thank you very much.